Hello everyone, welcome to this course on OCI Compute Service. My name is Rohit Rahi and I'm part of the Oracle Cloud Infrastructure team. In this module, we'll describe the OCI Compute Service. We'll look into the various compute instance shapes, lifecycle, images. We'll explain advanced features such as instance configuration and pools. And we'll create and launch a compute instance and walk through the features. So let's get started. The first thing to understand is OCI Compute Service supports bare metal instances and virtual machines. As the name specifies, a bare metal server or an instance gives you direct hardware access. Customers get the full bare metal server. There is 0% performance overhead. Sometimes this is also referred to as the single tenant model. So you get the actual physical server, but with all the advantages of automation, DevOps, fast provisioning, pay as you go, infinite scaling in the cloud. On the other hand, we also support virtual machines where we use a hypervisor to virtualize the underlying bare metal server into smaller VMs. Excuse me. So in this case, this is also referred to as a multi-tenant model. And as you can see here, we have the bare metal server and we run a hypervisor on top of it. And then we slice the available compute cores into a smaller number of VMs shapes, which we make available to the customers. The important thing to keep in mind that the VM compute instances runs on the same hardware as a bare metal instance, leveraging the same cloud optimized hardware, firmware, software stack and networking infrastructure. So for you, what it means is the API is the same. So you could use the same API to spin up a 52 core bare metal server, or you could use the same API to spin up a 1 core virtual machines. And the good thing is you could interoperate between them. For example, you can spin up a development environment using a 1 core VM, but when you are ready to deploy in the production, you could deploy the same code, same API, but on a 52 core bare metal machine. So that's why one of the reasons we have built the cloud from ground up, and we have kept this design consideration in mind, where both the virtual machines and the bare metal instances have the same stack. The other way to think about it is the virtual machine service is actually a first class citizen of the bare metal service. And if you recollect, a couple of years back when we launched Oracle Cloud Infrastructure, we started with the bare metal compute service. Now, as we said, bare metal gives you the direct hardware access, but with all the security capabilities, elasticity and scalability of the cloud. So what are the use cases for bare metal server? Well, workloads that are performance intensive. Think about it, databases, good candidate to run on bare metal. Workloads that are not virtualized, there's still a class of workloads which is not virtualized, whether it's for performance, security, whatever reasons, those workloads are good candidates for bare metal instances. Workloads that require a specific hypervisor. So you can run anything here, bring in KVM, bring in Zen, bring in your hypervisor of choice, right? You could run those on the bare metal instance. And finally, if you have workloads that require specific bring your own licensing, so whether it's SharePoint or Windows Server or some other software, you could use them on the bare metal instance. Now, for the bare metal instance, we support various shapes, and you can see the standard X7 shape here, 52 cores, 768 RAM. It's only block storage, and you can see a network of 50 Gbps. On the other hand, we also have a dense IO shape, where everything else is the same, but it comes with a 51 terabyte of local NVMe SSD drives. So if you have a high performance database which you want to run with it, you could run it. You get literally millions of IOPS which you could use. Then we also had previous family X5 shapes, same kind of configuration, standard and a dense IO, but the price performance is much better with X7. This is the current gen, so always a best practice is to go with the current gen, and the cloud provider takes care of upgrading these instances on a regular basis, right? So you should leverage and always use the latest generation compute instances available in the cloud. Now recently we have launched AMD EPYC based instances, and you can see the specs here. 64 OCPU, 50 Gbps network, block storage, half a terabyte of RAM, and we also recently launched, this is actually pretty new, just a couple of weeks back, we launched at HPC's Shape, and you can see some of the specs here. 36 core, 384 gig of RAM, and look at this network. I think we are the first cloud to offer 100 Gbps RDMA interconnect. So if you have HPC workloads which are absolutely performance intensive, you could use this particular shape. Now, what are the use cases for AMD EPYC based instances? So the biggest use case is on price performance. So as you can see here, the AMD instances are available at 3 cents core per hour, and these are anywhere from 66% to 50% cheaper than other options available with other cloud providers. So these are ideal for maximizing price performance. They are supported for Oracle applications. So if you have eBusiness Suite, JD Edwards, PeopleSoft, you're running in the cloud, why not use and run them on AMD EPYC instances, because these applications run on those on that processor type. It's also certified to run big data workloads from Cloudera, Hortonworks, MapR, etc. And we have run some performance benchmarks. I don't have those in the slide right now, but the summary is provided here. On a 10 terabyte full Terasort benchmark, the AMD EPYC based instance demonstrated a 40% reduction in cost per OCPU versus the x86 alternatives. Similarly, on a 4 node 14 million cell fluent CFD computational fluid dynamics simulation of an aircraft wing, the AMD EPYC based instance demonstrated a 30% reduction in cost along with a slight reduction in overall run times compared to an x86 alternative. So this is an HPC scenario. This is a big data scenario. As you can see, for any kind of scenarios where you want to maximize price performance, whether it's big data, whether it's HPC, AMD based EPYC instances are a good fit. So if you're thinking around those lines, do give these types a shot. For the virtual machine instances, you can see the standard instances here. The standard instances don't have any local storage, so each of these have just the block storage, and you can see the various specs here, the CPU, RAM, etc. You can also see the AMD EPYC instances listed here, and some of the specs for them. Now, similar to the bare metal, we also support dense IO VMs. The difference here is that you get some amount of local storage, anywhere from 6.4 terabytes to 25.6 terabyte of local storage, and you can see the specs here. We also support GPU instances, both Volta and Pascal, and again you can see the specs here. So if you have HPC workloads where you require a GPU instance types, you can use them with Oracle Cloud Infrastructure. Now we just looked at the various shapes possible for both bare metal and VMs, AMD EPYC, GPUs, etc. Let's look at some other characteristics of the compute service. So the first thing is we have this thing called an image. An image is a template of a virtual hard drive that determines the operating system and other software for an instance. Images can be Oracle provided, custom images, or you can also bring in your own image. Oracle provides several pre-built images for Oracle Linux, Microsoft Windows, Ubuntu, other flavors of Linux like Ubuntu and CentOS, and you can see all the various flavors which we support here. Now, if you go to Oracle provided images, let's talk about Linux and Windows for a moment. So for Linux images, there is a username which is called OPC. It's created automatically when you launch instances using Oracle Linux or CentOS. Now, when you use Ubuntu image, there's a username Ubuntu you have to use. Now, these users have sudo privileges and are configured for remote access over SSH. You could create your own users, absolutely, but these users have sudo privileges. Now, there is a default set of firewall rules which allow for access on port 22. Similarly, you could create Windows images, and you have to open port 3389. There's a username OPC. You get a one-time Windows password which you have to change, etc., etc. Right? You can read about all this in the documentation. Now, there is also concept of custom images. Think about these as your gold images. So you can create a custom image of an instance's boot disk and use it subsequently to launch other instances. The instances you launch from your custom image include all the customizations, configuration, and software installed when you created the image. Now, as you do this, instance shuts down and remains unavailable for several minutes. The instance restarts when the process completes. Custom images do not include any data from attached block volume. The important thing to keep in mind, it is only relevant to the boot disk. So whatever you have on the boot disk is there, doesn't concern itself with the block volumes at all. There is another way. If you want to preserve that data, you can just preserve the block volumes, because the block volumes are storage on the network anyways. Custom image cannot exceed 300 gigs, so there's a restriction on there, and the Windows custom images cannot be exported or downloaded out of the tenancy. So the whole idea is, if you have gold images, let's say you install certain configurations, you have a hardened operating system, for example, you want to change certain things, so you get the Oracle provided image and then you customize it, right? And you can use it subsequently to launch your other instances, or you can mandate orgs or folks within your organization to just use your own custom images and not use any other vanilla or Oracle provided images. There is also a feature called image import export. Compute service enables you to share custom images across tenancies and regions using this feature of image import and export. Now, image import and export, as you can guess, uses the OCI object storage service. So the image is stored in the object storage service, and this service has an endpoint in all the regions. So you could get the image, let's say from Phoenix to London. This is one way for you to get the image. Otherwise, it's a very manual process, and you can also use it across tenancies. So if you are a partner ISV and you have an image which you want to share with all your customers, you could use this feature. You can import Linux and Windows operating systems, and there are various modes which we support, different kind of characteristics. So there is something called an emulation mode, which is for fully emulated NIC boot and for legacy BIOS, and there's something called native mode, which is basically what you would use with modern operating systems. So you can read about all the details here. There's a white paper which talks about all the details on how you can use custom OS and use the image import export functionality. Now, as I said in the beginning, we provide you images, Oracle provided images. You can customize these images. You could use a feature like import export. So you customize your images. You could share it globally, for example, or across tenancies. You can also bring your own image, and this is particularly useful in case of OCI, because one of the key target scenarios for us is migration and using your existing apps. So for that, you could absolutely bring your own images. So you can also bring your own hypervisor. We talked about the fact that we support bare metal instances. You can run anything here. You could run KVM, you could run Zen, you could bring your own hypervisor, and you can configure your guests. You can run your own VMs. You can also bring Oracle VM if you're using that, and there are more details on how this works. We have a level 200 course where we go into more details. But the whole idea is to make it work. We support something called emulation mode virtual machine, and this uses different formats like QCOW2, VMDK format, and the idea is you run these compute VMs using emulated hardware. And you can see here there's a list of different operating systems we support, a bunch of these legacy operating systems, and if you have applications which are using these, absolutely feel free. You should leverage OCI, and you should bring these apps to run on OCI. Now, so we looked into images, the Oracle provided images, custom images, bring your own image. Now let's change gear and look into boot volumes. Boot volume is nothing, a compute instance is launched using operating system image stored on a remote boot volume. So boot volume is nothing but where your operating system resides. Boot volume is created automatically and associated with an instance until you terminate the instance. Boot volumes are encrypted, as you can guess, have fast performance, lower launch times, and higher durability for both VMs and bare metal instances. Compute instance can be scaled to a larger shape today by using boot volume, so that's another use case. And you can preserve the boot volume when you terminate a compute instance. They are terminated only when you manually delete them, and when you are running an instance, boot volumes cannot be detached. So think about where you keep your operating system and you launch your instance. That's the boot volume, and they have certain design considerations. You cannot detach them, you have to manually delete them. You can preserve the boot volume when we terminate a compute instance, and you can run a larger shape by using these boot volumes. You can take a manual backup, you can assign a backup policy, or you can create clones of boot volumes. Later on, we'll look into a course on block volumes, and boot volume is a special kind of a block volume. It's a storage volume which exists on the network. It's not really attached to the compute instance like a direct locally attached disk. So because of that, you can take a manual backup, you can assign backup policy, or you could create clone. All the characteristics, all the features you get with block volumes, you also get with boot volumes. Now you can also custom these boot volumes. You can specify a custom boot volume size, and you can see for Linux we support the default is 46 gig. You can go as high as 32 terabyte. In case of Windows, the default is 256 gig, but you could go again as high as 32 terabyte. Now what are the pros and cons of both these approaches? So with a custom image, one of the biggest advantages is you can export a custom image across regions and tenancies. So if you have a use case where you have a global organization and you want to use the same image across all the Oracle Cloud Infrastructure regions, you should use custom image in that case, because you could leverage the import and export capability there. There is no cost associated to store your custom images. These get stored in the object storage, but you don't pay for them. The downside is the instance remains unavailable for some time, and there's a limit to how many custom images you can store per compartment. Now if you have a boot volume, you can always take a backup of that, right? If you change some things, you can take a backup of that. The advantage here is it doesn't require a downtime. It's real time, don't have to bring it down. It preserves the entire state of your running operating system as a backup, so you could use that. On the other side, the downside is if backups are stored in object storage and you pay for that. And then the other problem with boot volume backup you might run into is while you take a backup when the instance is running, it creates a crash consistent backup, and sometimes it might have you might run into issues with this kind of a crash consistent backup, right? So just keep that in mind as you are using boot volume backups versus custom images. Now there is a new feature we have launched recently, around a few weeks back, which is called instance configuration and pool. So let's look at what this is. you can use a feature called instance configuration to define the configuration information to launch a compute instance. What does it mean? It means that you can include parameters like operating system image, metadata, and shape and related resources as a single configuration entity, so you don't have to specify them every time you launch a new instance. You can configure attached storage volumes, the virtual network interface cards, subnets, AD placements, all within a single request. So the idea is, if you create a template of an instance, you create a configuration, and you can use that configuration to launch as many instances as you want. You define that once, and you can reuse it multiple times. There's something called instance pools, which provision and create multiple compute instances based off the same instance configuration within the same region. So the idea is, you take the configuration and then you create a pool, and you can specify the number of instances you want in the pool. Of course, they have to be in the same region where your instance configuration resides. You can scale up and down the pool, so you can go from 2 instances to 20 instances and vice versa, and it's very convenient to do that. So this is useful if you're getting a lot of request and you have to handle the load. You can easily configure the pool to go up and down. And today we don't support auto scaling, but it's on the roadmap. It's launching pretty soon, and this is the backbone on which the auto scaling capability is built. One pool is based on one configuration, so you cannot mix and match, but one configuration can be used across several pools with different sizes, or different kind of parameters, storage volumes, VNIC, subnets. You could create different pools using the same configuration. There is also the instance metadata service, which runs on every instance and is an HTTP endpoint listening on this particular endpoint, IP endpoint. It includes the OSID, name, compartment, shape, a lot of characteristics for the instance, which is all available in the instance metadata. You can log into the instance and you can use the metadata service. It's running on, if for example, if you run the commands curl this IP address /opc/v1/instance, this is for the Oracle Project Linux instance, you can get the metadata, and you can even go to find specific values. For example, if you want to find the key value pair, you could actually just do /key name and you can get that information. Now it's also possible to add and update custom metadata for an instance using the CLI or SDK. Finally, on the instance lifecycle, start an instance, you can start and stop an instance. Stop shuts down the instance. Reboot, you could shut down the instance and then restart it, or you could terminate the instance. When you terminate it, you permanently delete the instance, and you can preserve the boot volume, for example, right? You can preserve the virtual network interface cards. You can preserve the other block volumes you are using. When you stop an instance, for the standard VMs and the bare metal instances, you don't pay anything. The billing pauses because they have no locally attached disk, and everything boots from a remote boot disk, so you really don't pay for any billing. There is no billing. But for high IO bare metal instances and dense IO bare metal instances and VM instances, billing continues even in the stop state, because these again have local storage. So even if you stop the instances, you still are paying for these instances because of the presence of the local storage. So with that, we covered a lot of ground. Let's look at a quick couple of demos on the compute service. So first thing I'll do here is I'm logged into my OCI console. We saw this in the previous courses where we created a virtual cloud network and we were using this compartment called training. So before I go into my compute service, let me make sure that I have a virtual cloud network up and running. We created this network called VCN2 as part of our VCN course. And this is a simple VCN. This is the CIDR block 192.168.1.0/24, and we have two subnets. There's a public subnet running in AD1. It has a CIDR block of 192.168.1.0/27. There's a private subnet running in AD2. It has a CIDR block of 192.168.1.32/27. They have different route tables. So there's a private route table here, there's a default route table here, there's a private security list, there's a default security list, right? It's really straightforward sort of a network design. Now I'm going to leverage this network for my compute instances. So first let me go ahead and create a bare metal instance. So I would come in here to my compute service. It asks me it provides me a name which is generated on using the date. So 2018, it's November 26th, actually 1 a.m. in the morning. So I would just provide a name here. I would say this is my bare metal machine, bare metal instance, or I'll just say BM instance, and which AD I want to use. AD1 is fine. Oracle Linux image, if I want to change it, I get a bunch of options here. You can see Ubuntu, CentOS, Oracle Linux, Windows Server. There's Oracle provided, there's partner images, there are custom images, etc, etc, right? So if I have, let's say if I have a partner image I want to use, I can use it here. If I want to use, let's say I'm running EBS or PeopleSoft or something, I could run that image here. I have platform images. I'm okay with Oracle Linux, so I'll just use that same Oracle Linux 7.6, and right here I can choose between a virtual machine and I can choose a bare metal machine. It says, as you can see here, it says a virtual machine is an independent computing environment that runs on top of the physical bare metal hardware. We talked about this. VM is a first-class citizen of the bare metal service, and the bare metal service is the dedicated physical server for highest performance and strong isolation. Those are the two key characteristics, and there is 0% performance overhead here. So once I choose that, I have to change the shape. So if I click on that, I get a choice of 52 core standard bare metal. I can choose the AMD EPYC instance here. I could choose the dense IO instance, or I could use the GPU instance. These are the ones we saw on our slide. In our case, I'll just choose the standard 52 core machine, and I'll say select shape. Now right here I can specify a boot volume, a custom boot size. So if I wanted something to be bigger than 46 gig, in this case 47 gig, I could do that. I have an option to use a key management service. So we have a key management service which I can use to bring in my own keys and encrypt my boot volumes, for example. I could do that. Right now I'm not using that, and right here I provide my SSH keys, the public portion of my SSH keys. And once I configure my the kind of compute instance I want, I need to pick up my network. So I would say I'm using VCN2 network, which we created in the VCN course. It's part of my training compartment, and then my subnet is the public subnet because I want this to be a public instance. And with that, I click on create, and you would see that within 5 minutes or so, less than 5 minutes, 3 minutes or so, my bare metal instance would be created. As this is happening, let me create another virtual machine instance. So I would create a web instance, and I name it web. I use Oracle Linux 7.6, it's fine. VM, I'm okay with that. Let me just, when I choose a virtual machine, I get a choice of 1 core to 24 cores, both for Intel x86 as well as EPYC, AMD EPYC instances. And I can also choose the dense IO instances which have local storage here, which we saw this in the slide. So I would pick a 8 core machine right here, right? And I would say the shape looks good. Provide my SSH keys, the public portion, that's good. Now let's look at and choose my network my VCN and the subnet. Public subnet is okay for this instance as well, and I'm choosing my virtual cloud network as VCN2. Now let's look at some advanced options. So the first thing I see here is I can choose my fault domain. We didn't cover fault domain in the compute course, but within an AD you get 3 different fault domains, and think about fault domain as your hardware and infrastructure which is completely isolated from each other. So you get a choice of 3 fault domains, and they have their own hardware infrastructure, top of rack switch, power supply, etc. So for example, if you're running a cluster, you can distribute your instances across the fault domains, so they would not be impacted simultaneously, or at least one of the fault domains will always be up and running. So it provides another HA construct within your availability domain. So if you don't want to do cross AD architectures across multiple ADs, which is best practice to do, you could always think about doing just having HA within the AD, or you could do both for the best possible scenario. So right here I can choose my fault domain. If I had not chosen it, Oracle would choose one for me. So just for the sake of it, I would choose fault domain 3, and right here I can provide my bootstrap script, my startup script, right? So I can provide a script here which says that poll my instance metadata service and provide me some show me the variables, right? And before that, install an Apache server. So once I do that, I'm literally bootstrapping my instance, and I can also provide a tag here. So I click create, and now you would see within a minute or so my compute instance would be up and running. So if I go back to my console, I can see my bare metal instance is still getting provisioned. My virtual machine is getting provisioned. As these are getting provisioned, let me go back to my console, and in the virtual cloud network course we created this particular instance called Web1. It's basically has one core VM, and it's running in the public subnet, the same subnet as the other 2 instances are. And as you can see here, it has a fault which is running in the fault domain 2. Now let me create an instance configuration here. So I click on create instance configuration, provide a name, and that's pretty much it. Now literally this configuration is created. This is the template. You can see that it's running Oracle Linux 7.6. It's a VM, it's a 1 core machine, 15 gig RAM. This is my boot volume. I haven't customized it, it's same boot volume. And now what I could do is I can create an instance pool here. So I click on attached instance pool, and actually I create from here, create instance pool, and now it says how many instances I want. I want 2 instances, all looking similar, and it gives me a choice of putting them in AD1 or AD2. Now if I choose AD1, I have this VCN2, right, and I can choose a subnet which is my public. If I provide additional selection, I could go to AD2, use the same network, and I have a private subnet here, right? So I could actually use this kind of configuration. So if I click on create instance pool, now what you would see is I have 2 instances created as part of that pool, one running in a AD1 in a public subnet, the other one running in AD2 in a private subnet. And this is very useful if I want to rapidly scale up or down. I could just come and change my instance pool. Now let me go back to the compute service main page and see if any of the instances are up and running. So as you can see, we literally been a couple of minutes, my bare metal instance is up and running, and if I click here, I can see some of the characteristics. It goes into fault domain 2. It has 52 cores. It's running Oracle Linux 7.6. Right here you can see the image, and I get a public IP, I get a private IP address. And right here you can see that if I click on attached VNIC, I can see that we have a primary VNIC, private IP address, fully qualified domain name, a public IP address, and so on and so forth. And there's a boot volume here, and I can see that this is my boot volume. Its size is 46.2 0.6 gig, 0.7 gig. Now a few more things I can do here. I can click on my virtual network interface card and I can get more details here, right? I can create additional private IP addresses. I can in fact create additional virtual network interface cards. If I wanted, I could do that. I could create virtual network interface card here. So the various options I could leverage. Now this is a level 100 course, so we don't go into a lot of details, but you could use those. As you can see here, I also can do things like console connections. So this literally pokes a hole and gives me access to this instance. So if, for example, if this instance was running in a private subnet, there was no SSH, nothing, I could still use the console connection. I would use it for things like troubleshooting. If I want to see what's going on, if there is problem with my fstab file, if there is a problem with my network configuration, I lose my, for some reason, I'm not able to connect to the instance, I could always do those troubleshooting using console connection. Again, in our level 200 course, we get into more details on things like console connection. Now if I go back to my the one thing I wanted to show is, if I go back to my compute service menu here, I see my boot volumes. So bunch of boot volumes. We created a few instances. Each of these instances have their own boot volume. So you can see that the bare metal instance boot volume is here. If I want to come here and I want to delete it, I cannot delete it, right? Because it's grayed out. Because the instance is up and running. I cannot resize it because the instance is up and running, but I can create a manual backup. I can create a clone. When you do a backup, it goes to the object storage. When you create a clone, it is a clone in that data center itself. It doesn't go to the object storage. I can assign a backup policy which says take a backup every day, or every week or every month. I could do that. Other bunch of things to see here. So this is just basically all the boot volumes. As we talked about, there is something called custom image. So right now I don't have any custom images. If I go back to my instances and the instance we created in the VCN course, web 1, I can click here and I can say create a custom image, right? So if you say custom, and it takes anywhere from 5 to 15 minutes, and my custom image would be created with this particular from this particular instance. Now, as we said, when you create a custom image, the instance is taken offline while the process is being done, and once the custom image is created, it comes back online. Now I can always come into my custom images and I can import an image, and you can see that as I started taking the custom image, it appears here. Now once it's up and running, I can export the custom image. I can also import a custom image. If I knew the URL, object storage URL, I could provide that value here. I could provide the different modes. There is emulated mode, there is native mode, there is also actually a new mode which we didn't cover in our slides, called paravirtualized. I could use that, right? And this could be an object storage URL from Ashburn or London, and I could create this image now in Ashburn. So I could do cross region, I could do cross tenancy. I have different options which are available. Okay, so let's get back to the slides. This is the pricing for the compute instances. The pricing is based on OCPU per hour, and you can see it's 6.38 cents per OCPU per hour. You can look at the pricing for the virtual machine, and the pricing for the bare metal is similar based on the OCPU per hour. And you can look up the pricing for GPU. So to summarize, compute service offers both bare metal and virtual machine instances, VM instances being the first class citizen of the bare metal service. Bare metal instances provide direct hardware access. Two main advantages: highest level of performance, 0% performance overhead, and isolation, the best isolation possible, the single tenant model. The VMs and the bare metal run on the same stack. We talked about this. We offer a wide variety of shapes with industry leading price performance, particularly for both for x86 as well as AMD EPYC instances. We support both x86 and AMD EPYC instances. Various options to have your images. Use Oracle provided custom images, bring your own images, and we looked into advanced features such as instance configuration and instance pool. So with this, thanks for attending this course on the compute service. I really hope this was useful, and I look forward to seeing you in the next courses on OCI storage services.